Hello, please join me in this video where I am going to talk about regioselectivity of an epoxide ring opening reaction. Such regioselectivity is controlled by the type of reagent used. For example, when strong bases or strong nucleophiles are used, then the ring opening is driven by the steric effect. Okay? So, like in this case, we do have a primary carbon versus the tertiary carbon. So, the nucleophile or the base will attack the less substituted position, the position that is less sterically hindered. And then it opens the ring in one step, and then followed by a proton transfer to install the nucleophile in that position. However, when weak bases or weak nucleophiles are used, which require acidic conditions, then the ring opening is driven by electronic effect. For example, let us look at this scenario where we first of all do a proton transfer, and then the intermediate form, we need to determine which position is going to be attacked. So we do have secondary position versus the tertiary position. We know that the tertiary position is, in this case, is going to be more electron deficient. Okay? It's going to be more electron deficient. Think of this as an SN1 or an E1 reaction. Okay? Where the stability of the intermediate is going to be the one that drives the reaction. So then the nucleophile is going to attack the position that is more electron deficient. So it's going to attack the tertiary position. And that's going to be followed by the proton transfer leading to the formation of the product. Whenever a hydrogen halide is used, then the reaction is controlled by both steric and electronic effects. In this case, we have primary and secondary. Now, we know that primary or secondary type of carbons will not be driven by electronic effect because they never form stable intermediate. So here we can say that this reaction is going to be driven by the steric effect. So after the proton transfer, then the nucleophile is going to attack the position that is less sterically hindered from the product. However, if we do have a tertiary position versus the secondary position, then the electronic effect is going to be the one that controls the reaction. So after the proton transfer, then between the tertiary and the secondary, the one that is more electron deficient is the tertiary position. So the nucleophile attacks the nucleophilic attack happens at the tertiary position to form the product. Thank you for watching and have a good one.